Oh, hey, what's up?
Alright, it's recording.
What?
We're recording.
Oh yeah. Let me put on my reading voice. Currently, somewhere 378 million kilometers away, on the deep, barren red planet of Mars, lies a lonely robot drifting around.
This is Perseverance, a Mars rover standing at an approximate height of 7 feet tall, 9 feet wide, and 10 feet long. Perseverance, or Percy for short, is responsible for examining the surface of Mars.
But as exceptional as Percy is, there's a different star in today's show.
Contained in the frame of the rover lies a fascinating device, a golden box.
This box is the Mars Oxygen In-Situ Resource Utilization Experiment, or more commonly known as MOXIE. MOXIE is a device that's been developed by NASA to aid in the research of oxygen production on Mars.
Perseverance and MOXIE launched on March the 5th, 2020, and arrived on Mars on the 18th of February, the same year.
MOXIE was conceived by the Mars 2020 Perseverance team, a team of scientists and engineers from all over the globe working at NASA.
MOXIE's size is approximately that of a car battery, being 24 centimeters wide by 24 centimeters long and 31 centimeters tall.
MOXIE is capable of separating 10 grams of oxygen per hour, scheduled to work intermittently over the duration of the mission. Carbon dioxide makes up about 96% of Mars' atmosphere, which can be converted into usable oxygen with the help of MOXIE.
In order to support human missions on Mars, future oxygen generators must be 100 times larger than MOXIE. MOXIE's goal is to create oxygen for fuel so that spacecrafts can travel to and from Mars with much more ease.
To launch off Mars, human explorers need about 33 to 50 tons of fuel, about the weight of a space shuttle. Liquid oxygen on Mars could supply more than 3/4 of the propellant humans need for exploration on the red planet.
Principal investigator Michael Hedge once said, "When we send humans to Mars, we want them to return safely. And to do that, we need a rocket to lift off the planet. Liquid oxygen propellant is something we can make there and not have to bring with us. One idea would be to bring an empty oxygen tank and fill it up in Mars."
MOXIE is comprised of four main parts: the sensor panel assembly, the SOXY assembly, the scroll compressor, and its golden chassis. The sensor panel assembly takes signals from Perseverance and checks up on MOXIE. The scroll compressor pushes the abundant carbon dioxide on Mars into the SOXY assembly, which then creates usable oxygen by running the carbon dioxide through an electrical current in a process called electrolysis, which splits the compound into oxygen and carbon monoxide. This process is similar to a tree, inhaling carbon dioxide and exhaling oxygen. The golden chassis protects MOXIE from exterior dangers, and when in use, MOXIE reaches extremely hot temperatures up to 800 degrees Celsius, which is why its chassis and components are made out of heat-tolerant materials.
The introduction of new technologies that MOXIE brings will promote a host of new careers and opportunities. The employment rate of science and engineering jobs will rise. After all, STEM jobs have been growing exponentially, and it's no small part due to advances in technology that NASA has brought us.
With the introduction of new technology and careers, the attention and appeal of space will reach a high similar to that of during the time of the moon landing, resulting in the need for more courses and programs involving space travel, exploration, and research to help the aspiring students reach their goals.
Well, as of currently, few people have encountered MOXIE, and even fewer will get to use it. MOXIE, in its current form, is an experimental piece. It's a delicate, expensive, and extremely hard to produce machine. It's not quite useful on Earth and only applies to a certain subset of scientists, so it will likely not be accessible to many. But I believe in the future, when it becomes much more safe, worthwhile, and useful, especially involving space travel and Mars inhabitation, it'll be public.
And this begs the question, should everyone have access? And frankly, no. The high production costs, coupled with its rather niche abilities, makes it something that should not be available to just anyone. It releases carbon monoxide as one of its byproducts, and it can reach extremely hot temperatures, making it difficult to manage and maintain. The ownership of this kind of technology should be left in qualified hands.
A major force of development for Mars exploration and space travel is the physical environment of Earth. The Earth's condition has been deteriorating for hundreds of years. Its resources are running lower and lower every year. It struggles to support incredibly large human population. In the recent past, there has been a demand for exploring Mars. A major force for the development of Mars exploration and space travel is the physical environment of Earth. The Earth's condition has been deteriorating for hundreds of years now, and Mars might just be the solution. Mars has an abundance of untouched natural resources and tons of open land. With the help of technologies like Moxie, we may be able to ameliorate Mars' conditions to fit humans. And that's a wrap.
All right,
boys.
so well, you're still here. How about we answer some questions? The rules are quite simple. There'll be a multiple choice question up on the screen, and you simply have to hold up the number that you think the correct answer is. Simple, right? Oh yeah, and there's also, you got 10 seconds to answer. Okay, so question 1. What does MOXIE stand for? Number 1, Mars Oxygen In-Situ Resource Union Exportation. Number 2, Mounted Oxygen Institute Resource Uses Experiment. Number 3, Mars Oxygen In-Situ Resource Utilization Experiment. Or number 4, Mars Oxygen Incentive Research Item Experiment.
It's number 3, the Mars Oxygen Institute Research Utilization Experiment.
Yo, what the heck, man? Question 2. What temperature can MOXIE reach while being used? Number 1, 300 degrees Celsius. Number 2, 400 degrees Fahrenheit. Number 3, 500 degrees Celsius. Or number 4, 800 degrees Celsius.
It's 4. It's 800 degrees Celsius.
Dude, man, can you stop? Jeez. Question 3. On what day did the Perseverance rover land on Mars? Number 1, February 18th, 2020. Number 2, March 15th, 2020. Number 3, March 12th, 2020. Or number 4, May 21, 2020.
It's number 1, February 18th, 2020.
Bro, seriously, stop. You're just giving them the answers. Question 4. Just keep in mind that this information is most likely on your handout, so... Haha, anyways. Who was the principal investigator of the MOXIE project? Number 1, Joseph Peterson. Number 2, Michael Hetch. Number 3, Trevor Noah. Or number 4, Jason Chen.
It's number 3, Trevor Noah. No, I'm just kidding. It's Michael Hetch. Number 2.
Bro, you couldn't even pronounce his name right the first time you recorded this. And finally, the final question. Question 5. What percentage of Mars' atmosphere is carbon dioxide? Number 1, 93%. Number 2, 94%. Number 3, 96%. Or number 4, 97%. Think about this wisely. This is the last question, so you know it's worth the most.
It's 3, man. It's 96%. I promise.
Man, look, if they paid attention to the video, they would know. Just look. That was the last question. Okay, you can stop.